So for those of you playing along at home, it is 3:20. We are taking homework questions right now. So we have the question of, if I can write or not, we have the question of 4/5 x is not equal to, move this up, is greater than or equal to 8. Now here's the thing most people aren't realizing. This only takes one step to fix, or to get x by itself. And that step does not include making a decimal. Does not. Now it could, but that's going to make 2 steps. So Molly, give me your attention real fast. Just make sure you see this, then go back to that activity. So to destroy a fraction that is multiplied to your variable, we multiply by its reciprocal. Because the 5 on top will get rid of the 5 on bottom. The 4 on bottom will get rid of the 4 on top. So when we do that over here, we just have to put 8 over 1 and then multiply straight through. This becomes x is greater than or equal to 40 over 4. Well, that's really 10, right? So we can say x is greater than or equal to 10. That's the one step that will totally get rid of a fraction, because the 5 on top and bottom cross cancel, the 4 on top and bottom cross cancel. Not cross multiply. Please don't think that's what those circles mean. It's cross reducing, if we want to use the right word. It becomes 1. Other homework questions. Please ask them, because we're going to have we're going to have an actual mastery the week we come back from Discovery Days. We're almost done with this chapter. That's why we did that group mini mastery all together. Aurea? 623 question what? 92. This was that long homework. Robert's planning a house. Apparently Mr. Estes is going to move. No, probably not, because he lives really close to the school. He's painting a house. Oh, he's not moving. Okay, good. He has 35 cans of paint. That's a lot of paint, Mr. Estes. He has used 30 cans on the walls. Now he needs to paint the trim. If each section of the trim takes half a can of paint, how many sections of trim can he paint? Now here's the part where you could solve it, not following the directions, but the directions tell us write an inequality with symbols, words, a number, give your answer as an inequality. Because he doesn't have to use all of the paint he has left. Right? So really, if we process through this, he started with 35, he's used 30. How many cans does he have left? 5. If each section of trim, this is kind of a ridiculous problem. I will say this is not true, unless the cans are small cans. Maybe they're small cans. Maybe you got a deal on small cans. Takes half a can of paint. We're going to divide this by a half. But guys, this is a trap door. That is not division by 2. Dividing by a half means how many halves do we have? Actually, I should say it halves. H-A-L-V-E-S, which I dislike that. Remember, keep, change, flip is that little memory trick we use. This is 10. Now, does he have to paint 10? No. So he could paint less than or equal to 10 sections of trim. He could paint, it's on the board. It's the board game board. Always check the board game board. Sarah, is that a question or is your hand just open? I couldn't tell if you were waiting to raise it. Other homework preguntas. I just like rolling the R. Like sombrero. Except that R doesn't need rolled.
I don't even know it.
Other Aurea?
Okay, question 83.
Letitia wants to get at least a B plus. Ew, letter grades. She wants to get at least a B plus in her history class. To do so, she needs an average. Add them all up, divide by how many you have, An average of 86. By the way, guys, for anybody following along, this is from 623. Right? So if you're not looking at this, you should be if you're not done with your homework yet. So she's gotten scores of 90, 82, and 81 so far. The fourth test is the last one. So she knows she will only have 4 tests total. Well, what we're wondering is what can add with those to make an average of 86. Now, there is technically like a way that we can like math through this. No, I'm serious. So, if you want the way that you can math through and not use the 5D process, average 2 pieces together and then average 3 pieces together, and then that will kind of guide you in averaging the 4 pieces together. But if I average 82 and 90, they actually come out to be 86. So those 2 grades on their own already average 86. Because 82 is 4 away from 86, 90 is 4 away from 86. 86 is right in the middle of those 2 grades. This will not always work out though. So the thing that will always work out is doing the technical math of what we're doing is 90 plus 82 plus 81 plus, we'll call Z her 4th test grade, divided by 4. We want that to equal 86. If you have not done 83 yet, you should be writing this down. This is where algebra is ridiculously beneficial. If we 5D process this, I'm going to guess a number, try it, see if it works. Change my number, guess it, try it, see if it works. If we algebra this, the Z is the thing we want alone. Get rid of everything with it. Starting down here though, because everything over here has been divided by 4. So we are going to multiply by 4 on both sides. It's going to be 240 plus another, 320 plus another 24. 344. Somebody please grab a calculator and check that. What's 86 times 4?
Yeah, 344.
Yeah, I can do math like Mr. McCully now.
You would have guessed.
Yeah, 344.
But I wasn't. Guys, at your age, I absolutely could not have done that. It just comes with practice. I broke up the numbers and I said 4 times 8 is 32, but put a 0 on it. That's how I got the 320, as I was thinking out loud. And then 4 times 6 is another 24. Put them together, 344. So now, what's with Z? All of this nonsense extra. So add all those together, combine your like terms, and get rid of them. I believe, 160, 243, 253? Yeah, I think it's 253. So if we take away 253, 80, 91, I think. Oh, sorry, we can turn this off. It smelled like hand sanitizer in here earlier. Which just smells sanitary.
It just smells too good.
Sorry, we would have taken that away from both sides too. Now, you could have, hey, hold up. You could have used your 5D process to say, this grade is above what I want. Excuse me, this grade is below what I want. This grade is below what I want. So I'm going to need another grade above what I want. That's how averages work, right? They end up meeting in the middle. So guys, let me backstep a tiny bit. If we have any chapter 6 questions that you want to talk about, we should do that today. If we don't get to the lesson, whatever, I won't be heartbroken. So if you have other things from the homework that you want to talk about, especially people that aren't going to be here tomorrow to work with me, like please ask that stuff now, because when we come back, we can do the 626 lesson when we come back from Discovery Days, and like we'll have a test that week regardless. Because we have 626, 627, closure, and then it's time for the test. Maeve?
I was confused on B too.
B, the teacher decided to make the last test worth
That
twice
was weird.
as much as the regular test. How does this change the score that Letitia needs on her test to get an overall average of 86? So here's how that modifies, and really I should kind of color code it like this. Whatever they earn on that test, that's what we call Z, right? But if the teacher decides to weight it twice as much, that Z way up here is going to become 2Z. But then, what does it make it seem like the amount of test grades we've received? Does it still make it seem like we have 4 test grades? 5, right? So this is like if the final gets weighted twice as much, there were now 500 available points, right? Instead of just 400 available points, there are now 500 available points. And Nikki, at some point, I'm hoping you'll turn around and join us again. So now that multiplication by 4, this would have to turn into multiplication by 5. I'm going to just mess up my smartboard. So it would change everything by that weird factor of making it seem like another test grade. We'd have to redo the algebra again to deal with that. That's more of an extension piece of it. I'm not as worried about that. Hey Toby, either eat it or like do something else with it, but we're not going to play with our food because we're in 7th grade. The fact that you can have snacks in class is already us giving you some freedom. I shouldn't have to tell you to quit mummifying your arm with a fruit roll-up. Right? It's kind of funny, but it's funny because it's silly. Like, that I have to do this. It's not funny like we're all laughing with you. It's kind of like, oh, Toby can't eat a fruit roll-up. Now, I like fruit roll-ups, but come on. You're wrapping up your right hand, which is your pencil hand. You need to write. Other homework questions? Zach.
Let me see which one was first. It was this one. 96.99. That was about like triangles. Oh yeah.
So here's the tricky part with this one. We have to be able to see which side matches which side. Because similar or not, the orientation has been goofed with. So this, my short side of 8, it looks shorter than S, and either way we can kind of match up. It's got an obtuse angle over here at this side. It's got an acute angle over here at this side. So we can match up. It goes with 20, right? Now, the question is, what goes with my 35? We don't even need to answer that question until we get to the next part. Because if it just wants me to find the scale factor, and I know that 8 goes to 20, how do I get to 20 from 8? 2.5. So 2.5 is our scale factor. Sorry, my decimal looks kind of funky there.
So then you can multiply.
Yeah, now here's the tricky part.
Divide 35 by 2.
This S, well, and the other way you could solve this is if S matches T, this is impossible, but S matches the 35,
This reminded me of 5.
right? It's the bottom. The 16 matches the T. So if I want to go this way, Meredith is already telling us we need to divide because we're getting smaller.
Yeah.
So we would divide by 2.5 versus if I'm going this way,
You have to multiply.
we multiply by 2.5. Oh, right.
Never mind.
Okay.
When we get done with this, can you tell us a story from your childhood?
No, we have a math lesson.
Oh, you do?
Here's a story from my childhood. I went to math class. They taught me a lesson.
Whoa.
When I was your age, I think I was with Miss Father.
How do you remember these names?
Well, I hope you remember me a few years from now, maybe.
I was a little late. The only math teacher I ever really liked.
Hey, you still have more time in your math career. Don't count other people out.
I'm dropping out of math.
Counted all my elementary
Let's chat about 626 real quick, just to cover these situations. I bet we only need like 10 or 15 minutes to really talk about this. So, the question becomes, is there always a solution?
No.
And sorry about it, real life is not such a kind place.
We should sue life.
Yeah.
Sue life.
So, there is not a mathematical way to solve every single situation in the world.
Some of it's just like question mark.
Yeah, well,
When we do that equal thing and we can't tell if it's bigger or smaller or equal.
yeah. So now the start slide, for those of you that paid attention, said like get out your equation mat and algebra tiles if you want. So if you decide at some point you want algebra tiles, sneak up here to grab somewhere over there is probably an easier sneak to sneak. So when we're working with these equation mats, they start by telling us these things are equal. And in a situation like we see here, okay, x equals 2, okay, x equals 2.
Okay.
But every situation is not that simple. So if we think through these setups, I guess we could say, we're going to find some of these that are true and some of these that aren't. So guys, this is on your handout. If you don't have it, please come get it. This is on your handout. We're going to go through and write one solution, no solution, or many, like any amount of solutions. If I have my equation mat, we'll do this.
Oh, look at that. So pretty.
Here's my equation mat, right?
Oh, and I'm just gonna make a perfect straight line.
And I have an x on each side, like they're telling us in A. X is equal to x.
Okay.
What is x?
X.
Ooh, I need random cards. What is a day without random cards?
A good day.
A good day.
A really good day.
A very nice day.
I think you guys are gonna miss these.
Probably not.
I doubt it.
You're gonna be in the grocery store over summer, and I'll see you like aisles away, and just be like, random card, Lily.
So I'm gonna like run.
You can say it like everyone.
My mom's like
Where you're like,
that.
oh,
Actually, I would not put
Yeah,
it past you to pick up one of those phones and go on the PA system and be like, excuse me, we need Lily in aisle 5. Your random card has come up. Lily in aisle 5. All right, so
Be like Lily in aisle 5. What is this?
Savannah is still not here today, right?
No.
Woe to Savannah. Sorry, girl, you gotta feel better. Get healthy. Eat an orange or something. Lose. What is x here? Yeah, if x equals x, what is x? X is x? What does that mean?
It can be any.
If x is 2, is this true?
Yes.
If x is negative 7, is this true? If x is a million, is this true?
Yes.
If x is 400 billion quadrillion, some number I make up, is this true?
Yes.
Yeah. So wait, if somebody tells me, hey, x is equal to x, well, that means any number can go in. So guys, we have a cool mathematical symbol to represent any number. Well, not really symbol, it's an abbreviation. Please on your paper, right next to this, write ARN. And then off to the side, you should probably make a little code. That ARN, wow, I'm writing sloppy over here. Hey, calm down the judgment. ARN means any real number.
What is a fake number?
There are non-real numbers that just exist in a different like universe, if you want to think about it kind of like Marvel. So seriously, there are like multiple existences that we can think in. You're not going to be asked to leave our current existence right now. In high school math, you will look at what if there are other types of numbers that we haven't talked about before, and there are. Those are numbers that we can't physically work with in the real world. Like if I tell you go -5 miles, well, you can't actually do that. Every time you go, You're going positive, right? When you cover distance, it's positive. So it's more complicated than that, but there are numbers we cannot work with in the real world, and that's why they call them non-real numbers, because we can do the math, but it doesn't actually work. Now, if I tell you x plus 1 is equal to x, so I'm going to switch up what I have on my algebra tile or on my equation map. Turn to your neighbor and tell them what you think about x plus 1 equals x. Test out some hypotheses.
Like if x did 1, it would do pretty much equals 1. I've seen something like this online. You know, like, they like 2 equal 1. You got like 2x, and it was like 1x. And then you divide it by x, and it made 2 equal 1. So is that what you're going to do to us? That is not right.
No.
Yes.
Because that ain't true.
Incorrect.
Lydia, I swear I do not plan this. Your cards, I just shuffled, and your cards are just next to each other. Lydia, what's your thought? Give me an example where this could be true. Lily?
It's not possible because if you put 2 in there as x, that would mean x plus 2 equals 2, but that's not true. And same if you did 5. 5 plus 1 equals 6.
Now let's try some like maybe secret like, oh, this might work. What about like 0, right? 0 is a number we don't think about very often.
0 plus 1 would be 1, not 0.
Crap, you're right. What about like fractions?
No, because you're still adding 1.
Oh, why are you like?
Oh, guys, we shouldn't be friends with whoever wrote this
Oh.
because this is a bunch of lies.
Lies.
Now, in math, we don't normally really write the word lies, although you should on your notes, so you have that remembered in your head of like, wait, this is a lie. What we write is this symbol, which you might think of like, oh, that's like the no smoking symbol, but you don't see that as often because now all of Ohio's no smoking. When I was a kid, like restaurants, if they didn't have that sign, people were smoking up in there. That really means no solution. So if you need to write off to the side of your paper that circle with a slash through it means no solution, that literally means there is not a number that we know of that can make that true. Now be careful when you use this. You want to make sure that you thought through all possible options. Eric, you had your hand up. What do you got?
Yeah, I think what's possible for C is insert coin to continue. Sorry.
Insert coin. For C?
Yeah.
What, you want to turn a life into 2 lives?
It's a joke I wanted to use for a while. I think.
You're like, this'll work.
Just put it out there.
Yeah, go ahead.
I think C might be possible because
Pause. Turn to your neighbor and talk through possibilities. Eric thinks it might be possible.
Yeah, I did. X is 0, then it would be
You're so loud. Like, you and Nick are right next to each other, and every time I say turn to your neighbor, you're like, hey, class, I think. Now, so, yeah.
no, wait, no.
Whether you're 12 or 13 or 14 or 15, like if your ages start equal, your ages are always equal. But if your ages start not equal, like if you're 12 and Maeve is 13, then your ages will never be equal. Now that's kind of tough because of course there's overlap with ages, but ignore the overlap. Like if we just say you're 12, you're 13, I'm making stuff up. But like you won't be equal. So like I will never have an equal age to myself sister because she's 2.5 years older than me. So when I'm 30, she's 32. When I'm 32, she'll be 34. Like, we'll never be equal. But then this is a really weird situation, saying what number is equal to twice that number? So if we try out things like 1 or 2 or 3, that doesn't work. But there's one number.
No, there's two numbers. No, there's one. Zero. Zero and one. What doesn't work? Yeah, because two.
Olivia, your card is up. Tell us what you think. Hey, side conversations. Bring it back. Toby, lift it up. What do you think, Olivia?
So at first we thought it was lies, but then we realized that it works with zero. Because so if x is zero, then 2 times 0 is 0, which means x equals 0.
Does 0 equal 2 times 0? Yes.
Would that work in real math?
Yeah. So this actually, I think, is what you brought up, Nick, of like, oh, I saw this online. So if x is equal to 2x, don't write this. You do not need to write this. I just need your attention. If we divide by 2, and guys, let me make an announcement before I keep going on. This lesson and this homework will be picked up next Monday. Okay, because we have like 8 minutes left. We will not finish this lesson. We'll barely get through this slide. That's fine. We took homework questions. It's all good. Do not stress about getting this done. If you work on it, great, awesome. But do not stress about it. We will pick this back up next Monday. This is weird. You've never seen situations like this before. So to bring us back to what we're talking about, we've been stuck. We got some people not listening. We've been stuck in an algebra world where x equals something, a number. Sometimes that's not the case. So I was just talking over there, and you probably heard me because I can't talk quietly. My age is equal to my friend Dave's age, right? We're both 30 right now, and if you ignore the overlap in like the calendar year, I'm always equal to Dave, right? Dave and I are always the same age. Our birthdays aren't that far apart from each other. So when somebody says, oh, what's your age? They know what Dave's age is. Because my age equals Dave's age, that's like x equals x. No matter what age we are, my age equals Dave's. Gravity works. But my age does not equal my wife's age. She's a year and a month younger than I am. So when I turn 31, she'll still actually be 29. Then she'll turn 30, but I'll be 31, she'll be 30. When I turn 32, she'll then turn 31. We'll never, ever have the same age. That is like this, right? I'm a year older than she is. She'll never equal my age. This just cannot happen, that my age is equal to hers. This is like saying there's a thing that is equal to twice that thing. If I give Nick 0 pizzas and I give Luz twice that many, how many pizzas does Luz get? 0. So when x is 0 is the only opportunity this has to be true. Try negative numbers, doesn't work. Try positive numbers, doesn't work. Try fractions, doesn't work. 0 is the only option.
So is this just right? One.
Yeah, this is true. It's not lies. It is true, but only when x is 0.
One option.
Yeah, so you just write like x is 0. Now, the paper, the instructions on there say like write one solution or no solution. You can just write x equals 0. That shows you that there is one solution. Always remember our algebra rules, that we can do whatever we want. That's why I came down here. If we take that equation and try to apply our algebra, Nick, this is where, if you were talking about something on the internet, they were probably trying to confuse people with x divided by 2 equals just x, right? If I divide by 2, divide by 2. Well, but then I just loop back to here. So here's the other thing I could do. Instead of dividing by 2, could I remove an x from both sides? Yeah, I can remove an x from both sides. So if I minus x, ooh, I don't get 2. This is 0. 2x minus 1x equals 1x. That's how I algebra to solve. We algebra, right? We could have divided by 2, but that didn't really change what I see. This actually lets me isolate 1x. Guys, the trap door here is to think this equals 2. Do not just get rid of the x. I have 2 x's. I take away one of them. I end up with 1x. So if we come back up to D, actually, I want you guys to think through the rest of these. Take like 3 minutes on your own. Think through the rest of these. Try to see, is there a solution? If there's a solution, what is it? If not, is it no solution? Or actually, if there are multiple solutions, then we think it will probably become ARN. I'm going to walk around for that 3 minutes. If you have questions, I will come to you. Where's your paper? You're literally under the mark.
If it's 2, then it will work because 2 plus 2 equals 4.
But I know what D is.
Oh, yeah.
Now, is there a way you can algebra prove that? What could you do to both sides to get to that?
2x equals 0.
You can't subtract 2 from over there. Keep going. Try to figure out the algebra to get us there. Hey, what are you doing your homework when you got these to work on? Okay. So when you think through those, like, what are we allowed to do? Yeah, so how do we get to x equals 2? We can take away an x off of both sides, right? So if we think back to that algebra math work, so over here, if we take away an x from both sides, yeah, but what that's going to leave us with is positive x is equal to negative x. So we need to think through a situation that the positive value of a number equals the negative value of that number. Is there a number where that is true? The other thing we can think about is opposite, right? What number equals its own opposite? Is there any number that the opposite doesn't change? Yeah, and this is the number that we don't think about very often, but it is a number. What's the opposite of 0?
Yeah, one below. It's like the age thing.
The opposite of 0. So this is what's so hard to think about. The opposite of nothing, we want to say is everything, right? Like the opposite of 0. 0 is nothing. The opposite would be everything. But 0 isn't positive or negative. So when we say the opposite of 0, it just is 0. Now the opposite of 2 is negative 2. The opposite of 5 is negative 5. But 0 is its own opposite. So that one can also be x equals 0. So that's totally a trap door. Eric, how did you figure out how to solve D? The algebra we do?
Well, you see, you could remove x from either side.
Ah.
That's when you realize that, wait a minute.
So guys, the first thing Eric tried to tell me to do back there, because he put his paper away because he has no concept of time, he self-reports. He was like, can I take 2 away from both sides? Because he was just quickly trying to suggest stuff. I was like, well, is there 2 over here? No. So we cannot take 2 from both sides. But we could take x from both sides. Right? So if we take x from both sides, that leaves us, I'm just going to cover this up for now, that leaves us with just x on the left side and just 2 on the right side. So D is x equals 2. That is our answer for D. Now, Molly, what could I do to E?
You can take 2 x's off of each. You can take 1 x off of each side.
Yeah, we could take one of those x's off each side.
So then you're left with a positive x and a negative x.
So we're left with positive x on the left side and negative x on the right side. I'm going to put that down here. We're left with positive x equals the opposite of x. Shoot. Now I know Molly knows because we just talked it through, but Meredith, do you know?
Well, technically, if you were doing one of those like chart thingies, if there's a negative on one side and a positive on the other, you can just cancel it out, so it'd just be 0.
Ooh. Guys, like 2 or 5 or negative 7, none of those work. Because 2 equaling the opposite of 2? No, that's not true. But does 0 equal the opposite of 0? Yes. So in E, x actually equals 0. Always think about, could 0 work? It's the number that often gets forgotten about. And the last thing I'm going to say today, and this is super weird to think about, 0 is its own opposite. Right? Like, you as a human want to say, what's the opposite of nothing? Everything. No. Actually, the opposite of nothing is still nothing.
Because you don't have anything to have the opposite.
Yeah, you don't have anything to make opposite. So it's not like saying, what's the opposite of $5? Well, I owe you $5. No. It's what's the opposite of nothing? Nothing. All right, that is it. Have a wonderful day. We keep track of this. We'll pick this back up next Monday. Keep track of this. I think it's actually 5x. Let me double check it. What problem is that?
6.2.3, 81.
Okay, if you care, on 623, oh, it was 50. This got chopped off by the hole punch.
I know, I just said.
You can always check the ebook or skip it if it's a typo or it's my fault or whatever.
I just skipped it.
Some more spicy water to play you out.
Mr. Do you think 0 is a negative number or a positive number?
It is neither and both at the same time. Yeah, let that blow your brain.
Does it not have a name? Like that?
No, it is both positive and negative, and it's also neither positive or negative. Yeah, because the value of nothing is nothing, the opposite value of nothing is nothing.